Okay, so gerrymandering is, if I give you this question, both of these grids will be identical, and you know, they may be A and B or C and D or any two letters, but they're marked off with two letters for sort of representing voters, or city blocks full of voters that are primarily A or B or some such thing. Okay. We want to make A win once and B win once by the process of gerrymandering. And what we're going to do is we're going to create 7 districts, each with 5 squares. And the rules are, you can't, for example, you can't say, okay, this guy is part of a district with those guys. They have to be continuous so that you could walk through them. So you couldn't do like these 3 and these 2, because you're not allowed to walk across through the corners. You have to walk only through the edges. Okay. So one of the easiest things you can do is just say that's a district, and make them all in columns. That's just the easiest thing to do. And if you do that, you just do the columns, and then B wins this column, B wins this column, B wins, B wins, A wins, B wins, and A wins. And so B wins 5, A wins 2, so B wins. Yay. Okay. So that means actually B is the easiest one to make it win, because think about it. What do we have? Out of a total of 35, how many of them are A's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means 20 of 35 are B's. We can just like double check that to make sure we counted it right. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Let's try to make A win. And we're doing that by gerrymandering with a process called packing. So we want to make A win by packing as many B's together as possible. So for example, this is a set of B's. We're packing them in as tightly as possible. Is there another set that I could make? Here's a set of 5. Now I might not be able to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I can do that actually. And then what I want to do is, when I want A to win, I want A to win by the narrowest possible margin. So for example, A is going to win over here, and A is going to win over here. Now we have 2 A wins and 2 B wins, and so we still need to make A win at least twice more. Again, we can do the narrowest possible margin here by having A win 3 out of 5. And A can win. Oops, I'm going to break some rules there if I do that. Let's see. Well, I need to adjust something. Well, let me rearrange something. Let's see. If I did A could win this one, then what would happen? We would have, I don't know if this is going to work. Let me just try this. I would end up with a B win here, an A win, an A win, a B win, an A win, and an A win. So I'd have 1, 2, 3, 4 A wins, and B wins, and so A wins. Let's double check, make sure we didn't count something wrong. Let's make sure we did this correctly. So I'm going to see, I might have to make sure A wins at least 4 times. So does A win over here? Yep. And does A win over here? Yep. A wins over here? Yep. And A wins over here. Those are the A wins, and the other 3 are B wins, and so we're good to go. Which of course leads to the next obvious question: how many A's do we need to win well, we actually didn't need these guys at all. They didn't help us. And so if you think about it, on this size grid with these rules, you need to win 4 out of 7 districts are needed. And each district, so you need 3 per district. So 12 minimum A votes out of 35 might win. That's ridiculous. Okay, but that's the way it works.